I'm Chris Anderson with the EEWeb Tech Lab, and today I have a new 16-bit microcontroller starter kit from Lapis Semiconductor. Lapis is among the leaders in low-power MCUs, and these MCUs leverage Lapis's U16 CPU to blend low power with the performance needed for applications like IoT devices, LED lighting, motor control, and industrial equipment. Three new families, ML62500, ML62130, and ML62150, are available with different peripheral sets and features to address the needs of different applications, but all are based on a high-performance, low-power 16-bit RISC CPU. For this demo, I have the starter kit, which is based on the ML620Q504. Now in this case, ultra-low power consumption means 0.45 microamps in sleep mode and 250 microamps per megahertz in operation. I also have the nano-ease, which we'll use as a programmer debugger, and this ribbon cable to connect them. And the important part with the ribbon cable is that the ribbon with the red line needs to align with the pin 1 on each of the boards. So we'll hook that up. Before we plug in the USB, we're going to make sure all of our software is ready to go. To start, we'll go into the Quick Start Guide. And once we're in the Quick Start Guide, there's of course some information on the hardware. There's a link that provides you information on Lapis 16-bit MCUs. There's also a link to GitHub and a link to the Lapis support site. So if you go to GitHub, there's some more information, some documentation on the product here. You can see a block diagram. And if you go to the Lapis support site, while that's loading, we'll come back here. It says, please allow 1 business day for registration, confirmation, and access credentials. It didn't take a full business day for me, but it definitely wasn't instantaneous. So make sure you're registered, and once you get your registration confirmed, go ahead and log in, and we'll download all the software, users manuals, everything you need. So once you're in, there's a few places you'll want to go. First, you can come up here to the High Performance and Ultra Low Power MCU ML620-500 series. And this is where you can get data sheets and users manuals for the actual MCU. And then if you come to the Development Support System, you'll want to download the U8 development tools, as well as coming here to the reference board page. And this is where you can get all the information on the actual reference board that we're using. And before you leave, come to the Sample Program Application Notes section and download the ML620Q504 reference software. Once the DevTools downloads, extract that zip file, and you'll come in here to Setup, and then you want to install the U8 DevTools. So run setup U8 dev_e, and then you'll also want to run after that the device info setup. And when we finally plug in, if your computer doesn't find the drivers, you'll want to point it to this driver folder. And that's where you can find the drivers for the nano-ease, which are actually in the uease inst pack folder. Once everything's installed, go ahead and launch the IDE U8 GUI environment. There's a couple things to point out here. If you're on a 64-bit system, you want to come into Environment Settings, System Path, and add x86 to all of these. By default, they'll just show program files, not program files space x86, so you'll want to add that. And then you'll come in here to Other, under Environment Settings. If you're using the internal editor, I'd turn on the color construction. If you want to use an external editor, you can do that as well. For this, we'll go ahead and open an example. I'll back out of here so you can see where it's at. So I extracted the reference software to my desktop. And so from that folder, we'll go into Software, Examples, Timer, Normal Timer Mode Sample, and then load the .pid file. Now in this example, what it's set up to do is create a timer that will elapse after 1 second and turn on an LED and then go into an infinite loop and stay there forever. So if I come up here and click Debug, once it compiles, links, and everything's ready to go, we want to select the target chip as the ML620-504 and use the nano-ease for the target ICE. Hit OK. It's going to ask if we want to start debugging. Say OK. To actually run the program, you come up here to Debug, select the ML620-504 at the end of the list, and the nano-ease for your target. Hit OK. OK again. And I'll go ahead and load that to the MCU. And once it's done, come over here and hit Run Program. And after a second, the LED lights up. And that's all well and good, but everybody knows you want to do a blinking LED, right? So I have this modified example that will actually make it blink, so it will start the 1 second timer and then it will just toggle the LED on and off. So now with that pasted in, if we hit debug here, save it, we'll run through the process again. Hit OK, and one more time, hit run. And now our LED will blink on and off every second. Now, Lapis 16-bit MCUs are perfect for applications that require better performance than 8-bit can offer and greater power efficiency than 32-bit provides. Applications like sensor-driven IoT will benefit providing the user with the experience and battery life they expect. For more information, visit lapissemi.com.